In this video, I'm gonna go over some glancing collisions. You don't need to know the details like the way you will see that in this video and to be able to do this math for AP Physics 1, but you will need it for college, and you need to understand the concept behind these problems, not the whole math, the scary part. So I'm gonna go over a few questions and the concept related to the glancing collisions. Just as before, you will look at conservation of momentum. You will say the momentum that the system had before is equal to the momentum that is system going to have after if no forces were added or matter was added into the system during the collision. So I'm going to have before equals to after. The only difference for before and after is that I'm going to have vertical and horizontal components of the momentum. So before, my momentum initial is equal only to horizontal momentum. My vertical momentum initial is equal to 0 because the mass 1 is only moving in horizontal direction. So the momentum before is only horizontal, and it is equal to m1 v1 initial. Then afterwards, I still have horizontal. I'm going to make it in green for both masses after they collided. And I will have vertical. I'm going to make it in blue collision as well. So it will have momentum vertical and momentum horizontal. Vertical need to be canceled. So if after the collision, if this is angle theta and if this is angle phi, then your vertical part right here, because this is your angle, this part right here becomes V2 sine, and this part right here becomes V2 cosine, or the green part. So you have V2 sine and you have V2 cosine, and the same is for the blue ball. If this is your angle, then the blue part of the momentum is V sine, and the horizontal part, the green one, is V cosine, and the momentum has to be conserved. So the momentum after, so I'm gonna write the vertical one. So the momentum after final vertical is equal to m1, the blue ball, v1 final sine theta plus m2 v2 final sine phi. So that is phi. And all this needs to be equal to the momentum vertical before. And the same for horizontal. For horizontal, this is your momentum before. It must be equal to the momentum after. Momentum after for horizontal is m1 v1 final cosine theta plus m2 v2 final cosine phi, because you have this momentum horizontal and you have that momentum horizontal. So you have these two moving horizontally times the mass, and you have these two moving vertically at the same time when it's moving horizontally. And vertical must be cancelled, and horizontal must be equal to the one that you used to have horizontally before the collision. So this is the concept that you need to understand for the problem. Now let's look at some of the questions where we can use the numbers. So in this question, they say a 1.2 kilogram red ball moving to the right with a velocity of 17 meters per second strikes a stationary 2.3 kilogram blue ball. If the final velocity of the red ball is 13.5 meters per second at 23 degrees above the horizontal, determine the final velocity of the blue ball. And here we don't have vertical momentum, we only have horizontal momentum of the system before the collision. So we have to write, but afterwards they move vertically and horizontally at the same time. So we will break it into horizontal and vertical motion. So I'm going to redraw the picture so I can show you the velocities afterwards. So here I redraw the pictures, and we have horizontal components after the collision, so I'm going to make them yellow. and we have vertical components after the collision. Let's make them green. So the vertical components after the collisions are going to be green. And the vertical components are going to be velocity after the collision. Let's call this one V1 and this one V2. So here we will have V1 sine theta, and here we're going to have V2 sine, and that angle is phi. And here we're going to have V1 cosine theta, and theta is given 23 degrees. And this one is going to be V2 cosine phi. And then I'm going to write the momentum before is equal to the momentum after. Momentum before on x-axis, I only have m1 moving with the velocity. I'm going to call it v sub 0. And the blue ball is not moving, so there's no horizontal motion there. After the collision, I have m1 moving with the horizontal momentum of m1 v1 cosine theta plus m2 v2 cosine phi. And for, let me rewrite this, v sub 0. And for the y-axis, I don't have any momentum before the collision, and after the collision, it's the y components of the velocity. So that's going to be v1 sine, or I need the mass, m1 v1, m1 v1, and I have sine theta. And then the other one is moving in the opposite direction, so that's going to be minus m2 v2 cosine or sine phi. So that's what I have horizontally and vertically for my system. I'm going to plug in my numbers into wherever is known. So I have m1 v sub 0, I have m2, and I have v1, and I have theta. So if I plug in the numbers, this is what I'm going to get. So here I plug in the numbers for my m1 v sub 0, and then I have m1 v1 cosine theta, m1 v1 cosine theta, and then I have m2, v2 is not known, and cosine phi is not known, so I have all of those. And then I have 0, here's 0, m1 v1 sine theta, I have m1 v1 sine theta after the collision, and I have m2 v2 is not known, and sine theta is not, or phi is not known. So I'm gonna multiply the numbers to make it look a little bit easier, and let's see what we're gonna have. So I moved the numbers and I plug in the numbers and then subtract it from everything. So now I can actually divide both sides by each other. I can use this trick for math. Here's how it works. So if you have 2 times 3 is equal to 6, and 5 times 7 is equal to 35, you can divide both sides by each other, and they still get 6 over 35 is equal to 6 over 35. So I'm going to use this trick to solve the system of equations. So if I divide both sides by each other, 2.3 cancels, v2 cancels. And I'm going to divide this way, so I'm going to have tangent. So sine divided by cosine is going to give me tangent, theta. And if I divide the same 6.3 by 5.5, I get 115. So I can find theta is equal to arctangent, or the inverse tangent in your calculator, of 1.15, and that is equal to 49 degrees. So I found what that phi is equal to. The angle phi now is going to be equal to 49 degrees. So now, since we know the angle, so we know this angle, so we can plug in this angle, and I forgot this one is phi. So I can plug in this angle and find V2. I can plug it in into this equation actually. So I will have 6.3 is equal to 2.3 V2, and then it is sine of 49. So from here I see that V2 is equal to 363 meters per second. So we found the angle and we found the velocity of the blue ball after the collision. So what you have to remember in these the glancing collisions problems, you will not see the problem that I just solved on AP exam on AP Physics 1. You might have this type of question on AP Physics 2. So what you have to remember is the momentum before, and in this case, like right here in the one that we just solved, you have only horizontal momentum before. If you had both horizontal and vertical, you would have to write the equations for both horizontal and vertical before and after. So for this one, you would have the horizontal momentums of both before and after is equal to the vertical momentum of both before and after. And in this case, again, you would have no vertical momentum for either of the balls before, but you would have vertical momentums for them after. So these vertical momentums will cancel each other to give a 0, because your vertical momentum before the collision was 0, and your horizontal momentums, the both green arrows like these ones, so mass times velocity of those both must be equal to the momentum that you had before when one blue ball was moving before the collision. And so that's the concept that you need to know and remember, and that was all I wanted to show you about the glancing collisions and that you need to know for the AP exam. And thank you for watching. See you in the next video.